In this video, I'm just going to show you a quick example of using code coverage driven by a unit test to review some code. I'm about to do some refactoring. I want to look at the code, see what's covered, see what's not, make some decisions about it, and I use the code coverage to help me. So all the code that we're seeing here is it's on GitHub. It's part of my Challenger project. There'll be a link in the description. So let's just have a quick look at the test. So I have a test here. And the test is using mocking because I'm working at an external interface layer, which is the HTTP requests that are coming in. And I'm not comfortable with the way that I'm doing this, so I'm about to refactor the code so that I don't have to do the mocking here, and I'm working with internal classes. But I've got some coverage here, and I just want to have a quick review of the code to see what is covered. So the code that is actually being tested is over here. It's this Challenger Spark HTTP request hook code, and it's pretty simple. Given a request and response, it checks some stuff and goes through, checks if it's null. If not, it doesn't process it. Checks if it's a particular verb with a particular URL. If it is, then it does some stuff, and I can go through and see what's going on. And there's some ability to check whether someone is logged in or not. It's relatively simple code, straightforward set of ifs, nothing really complicated in there. So I'm going to run this test. I'm going to right click and I'm going to run this test with coverage. And what that's going to do in IntelliJ is run the particular coverage tool that I've chosen, which I think is Kokomo, and it's going to run the test with the instrumented code and show me the coverage that was achieved. So I'm going to say replace active suites here so I can see just the run from that. And we can see at a high level, pretty low coverage there, but I'm not really interested in the package coverage because this test is designed to cover a particular class. So I'm really only interested in this particular class here. And we can see that 100% class coverage because it's testing that class. 100% method coverage, great, but there's only 3 methods, so that's not that good. 78% line coverage, but that's not really good enough. And when we look at the code, we'll see that. Now, some people might stop at this point, thinking that they've got 78% and they're good. When we review it, we'll see that this code needs more than that. Different types of code, the way it's written, the way it's laid out, the way that it's architected requires more or less coverage. We make decisions about it. The number itself is not the guidance. So what I want to first of all do, in order to support my code review, I just want to zoom in on this. I only want to see this particular class in the metrics. So the way I'm going to do that is by editing the execution profile. And in here, in the run configuration, I'm going to go into code coverage. And rather than saying, I want you to look at everything in this package, what I'm going to say is, I want you to look at a specific class. And that is the Challenger Spark HTTP request hook. If I do that and say OK, then run the test again with coverage, hopefully I will only see that particular class in the output. Because I'm trying to zoom in on the specific area. So sometimes I'll have a test that is covering multiple classes. I'll want to only include those particular classes in here. So we can see that the only thing that's reported now in scope is that particular class. So I'm zooming in, I'm having the execution profile to help me review a particular set of tests and a particular set of classes. So I've zoomed in now. So let's see what we've got. So I know in the report there that it's saying 78% line coverage. Some people have standards. It must be, if it's 75%, we don't review it. Some people go up to 90%, some people 100. I think it depends on the class. So here in this particular class, we can see by the way it's written that we're achieving a lot of coverage no matter what we do. Right, because we're always going to hit this method. We're always going to go into this method. We're always going to hit this line. We're always going to have check this condition. We may not always return. So I know that I have something in here which passes this null and executes the return. So I probably have a test purely for that path, which is good. I can see that this is fully covered. So I have a test that says get these /challenges, and then presumably it checks that challenge is passed. Here, I can see that I've got some that's hit get and heartbeat, but hasn't passed. Now, this is interesting, because what I've got here is the reason that both these lines are passed is not because I have a test for get heartbeat. I have a test for get challenges. And this condition, get, is exercised for my test for get challenges because the way the code is written, it's a series of ifs. So I do this if, then the next if, then the next if. It goes through the whole code linearly. So because I'm passing in get challenges, we pass this condition because the method equals get. So this condition is passed. Because it's an AND statement, I have to also check whether the path equals heartbeat. In this case, the path doesn't equal heartbeat because it's challenges, but we've still achieved line coverage there. I haven't done the important thing, which is exercise the code under those conditions and make it pass, which is what the test will really be checking for. We can see here on delete, I've only covered half of this condition, where I delete, but I don't pass in heartbeat. So I can see that I don't pass in heartbeat because this isn't covered. Now, one of the things that's interesting here is the code formatting is helping me review this. I can see here that I've got delete and I don't have heartbeat. And I can see that because green, we covered the delete. Pink, we haven't covered this line, we haven't covered the heartbeat. What happens if I change the formatting here and rerun the test? So this is the delete heartbeat. So I'm going to go back to my test and run the test classes with coverage, run test with coverage, and we'll see what happens. Remember, all I've done is change the formatting, so I'm not expecting the numbers to change, and I'm not really expecting any different results at all. So I now have 80% line coverage. So before it was 78%. So by combining those lines, I've managed to increase the coverage. Go us, right? We didn't change anything of importance, but we're getting more coverage. So this is why some of the metrics are a little bit hard to take as just numbers. And also when I review my code here, I can see that this line, delete heartbeat, is showing as covered. Now I know it isn't covered, but I know why it's showing me this. It's showing me this because we have to exercise this if, because all the ifs are being exercised. So if method equals delete, it isn't, we won't go any further, but this is all in one line. We've achieved line coverage for this. Go us. So formatting makes a difference. So formatting makes a difference in terms of the reported coverage, but also makes a difference in terms of our ability to review that coverage easily. So when I review the code, I can see that I don't really need to care very much about the conditions. Right? Sometimes if we've got an if statement and these are all OR conditions, then I have to really care about the tests that are coming in, because I'll get line coverage from that whole condition statement, but it's an OR. So I need to say, does this happen? Or does this happen? I need to have tests for at least both of those coming through, potentially a neither, so that's 3 of them. I need more coverage. When it's an AND, I need to make sure that it doesn't go in and it does go in. And most of the time it doesn't go in is going to be covered by something else. So I need to make sure that I have something that covers that entire condition. And it's a little bit easier. Condition coverage, or the Boolean predicates within that condition, have to be analyzed because the coverage is not going to report on that level. The formatting might show me some indicators that certain conditions are there. But when I see complicated things here, I have to review it not just from code coverage, but what the actual test itself is doing. So in terms of line conditions, there are some lines here that are really important. Right? This challenges pass. This is the whole point of this method, to pass these particular challenges when certain conditions are met. And I can see that I don't have any coverage for this. I don't have any coverage for this. I don't have any coverage for this. So I know that there are gaps in the test code that is driving this. And regardless of whether I've got 76%, 78%, 80% coverage, I do not have enough coverage. And looking through this method, I suspect that once I've got tests for this, I will actually need 100% coverage on this class to have it tested to a level where I can trust refactoring over time. Because it's not really about the numbers, it's about how the code is written. And if this code was written differently, the line coverage would give me a better indication. If each one of these conditions I knew was completely separate, and after doing this, it just did a return and exit out the method, my line coverage at this point would be really low because I wouldn't even come through to hitting these methods. But because of the way the code is currently written, I'm getting a lot of code coverage from just exercising code rather than testing code. Now, what I find interesting is when I'm talking to people about coverage, when I talk about coverage, they very often hear code coverage. What I'm really talking about is test coverage. In fact, what I'm really talking about is model coverage. Code coverage is using the code as a model and showing us how much of that model we have covered when we have exercised that code externally by something else. Very often when I'm talking about coverage, I'm talking about a logical concept. I have a set of conditions in mind that I want to know whether they're coveraged. Code coverage is just a side effect, an easy way of measuring that. And some of those conditions may well be Boolean parts of an overall condition. They may be in an OR statement. Code coverage isn't going to tell me that. I have to know the model that I want to know covered, and I have to review the code coverage and the actual code that's been implemented and the test coverage and evaluate it separately. So when I'm talking about coverage, it's a bigger concept than just code coverage. If I haven't covered all the code with my test, then I know that either the code isn't related to the model that I'm trying to test, because when I write tests, it's not test to cover this code, it's test to cover a model, a set of requirements, a set of conditions, a set of states, it's a set of stuff that I want to know whether it happens or not. The fact that it's implementing my code is almost a side effect. And if I haven't covered all my code in my tests, then I know I've got a gap in my test coverage when I expect my test to be the full set of information about what that code is supposed to do. So I know I have gaps. So I'm going to go away, write more tests to cover this, and I suspect when I do, I will get 100% coverage because that's what's important for this particular class. Now in this example, I expect my test code to completely be the only thing that covers this. So I can run that particular test, I can focus in on that particular class, and I can get a good indication of, have I successfully implemented the model that I'm trying to do? The set of requirements that this test embodies, have they been covered in this code? I can use code coverage in a fairly good way to do that. I can see that there's a danger because I can achieve a lot of code coverage by exercising the code, not testing it. I could rewrite it to deal with that, but that's not my focus at this point in time because it's obvious to me that I have gaps. The conditions here are simply enough that I don't really have to worry about a lot of Boolean combinations. So that's good, but I can see that from the review in the code, not from the coverage metrics. By formatting the code differently, I get a better indicator that I've not covered it, but really line coverage will tell me whether I've met this condition or not. I don't really need to format it to see whether I've hit this condition or not, because when this condition passes, then I will have exercised this line. So I don't really have to worry too much about lots of different combinations and Booleans. I'm really targeting at this implementation set of lines, and line coverage, when it hits a high enough amount, will tell me that. So in this instance, I'm probably aiming for 100% coverage. Other classes might require more tests. Even when we've got to 100% coverage, I might require more tests because I have to cover more combinations. This is why numbers of coverage isn't good enough. We have to do the review in combination with the numbers, and in combination with the actual test, reviewing it, and in combination with the model that these tests implement, because it's really the model that these tests implement that we're trying to cover. And the code coverage is a side effect way of measuring that. Now, when I come back to write my code, I'm using this as a guide because I know there's a gap, but I'm not writing code to cover this line. I'm writing code to cover the gaps in the model that are implemented in the test and the code. It's the model that's driving this that I'm trying to cover, not the code, right? Tests are a way of implementing that coverage. Code coverage is a way of monitoring that coverage. But the model that sits on top of this is really the thing that I'm trying to cover. So when I talk about coverage, I'm really talking about that model coverage, but I can use code coverage as a tool to help me in my review process.